Hey, good morning, students. How are you? I hope everyone is safe at your place. And yes, I am too safe in my place. So, today we are here to learn the mathematics, in which today we will learn the chapter 3 triangles. As we know, in previous class we studied the theorem of remote, then interior angles theorem. Also we learned the 360-90 angle theorem. Again the median of triangle we learned. Properties of median of hypotenuse, which is also done in the previous class. Now today we will learn the perpendicular bisector theorem and angle bisector theorem of similar triangles. So let's start the perpendicular bisector theorem.
It has two parts, so we will see. Part 1. Every point on the perpendicular bisector of a segment is equidistant from the where endpoints of the segment. So what is given here? Given is the line L is the perpendicular bisector of segment AB at a point M, and point P is any point on L. So what do we have to prove? We have to prove that is PA is equal to PB. Now let's see in the diagram below. So what is given? Line L is perpendicular bisector of segment AB at a point M. So first draw a segment AB. This is the segment AB. The line L is perpendicular bisector of segment AB. Perpendicular bisector means the line L should be perpendicular to AB. So it is perpendicular. Let's give name L. And the line L is perpendicular bisector of segment AB at a point M. So this point should be M. So this is the given part. Also given is that any point from line L, let's give name P, is equidistant from the end point of the segment. Equidistance from the end point of the segment AB. Let's prove it. For that we need one construction. construction means we have to draw the segment AP and segment PB. Yes, this is our construction. Now the proof. First, in triangle PMA and triangle PMB. Segment PM is congruous is equal to segment PM. This is the common side of two triangles. So this is the common side. Now the second, triangle PMA and triangle PMB. They are the right angle triangle of adjacent triangles. So angle PMA is equal to PMB. These are the right angle now. Segment AM is equal to segment BM. MB or BM, which is given, which is the given part of the theorem. So therefore triangle PMA is equal to triangle PMB. This is the SAS test proof, that is side angle side test. Therefore the segment PA is equal to segment PB, that is CSCD. Therefore line PA is equal to line PB, which is we have to prove. Hence every point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. This is the proof. So part second, any point equidistant from the endpoints of a segment lies on the perpendicular bisector of the segment. This is the part 2 theorem of perpendicular bisector theorems. Here given is what? Point P is on the equidistance from the endpoints of AB, that is PA is equal to PB. And what we have to prove? Point P is on the perpendicular bisector of segment AB. Now let's understand with the help of diagram. Segment, let's first draw segment AB. This is the segment AB. What is given over here? any point equidistant from the end point of a segment lies on the perpendicular bisector of the segment. So here let's draw perpendicular segment first. And here any point on perpendicular is P. Now what is the next part is given is point P is any point perpendicular bisector of segment AB. Sorry, this is the point which is given, point P, and it is said that it is equidistant from the end points of the segments, that is A and B point. So this is the given part. P is any point on the perpendicular line of segment AB, and the distance of point P from the endpoints of segment A and B is equidistance, which is given. That means PA is equal to PB, which is given. Now what we have to prove? We have to prove that point P is on the perpendicular bisector of AB. So that is, we have to prove that this is the perpendicular line on AB segment. So for that we need one construction. Construction is take midpoint. Take midpoint M. M on what? Take midpoint of M of segment AB and draw line PM. So this is M. Let's prove this theorem. So proof. In triangle PAM and triangle PMB. In triangle PAM and triangle PMB. Segment PA is equal to segment PB, which is given. Second, segment AM is equal to segment BM. Segment AM is equal to segment BM. This is the construction because we take midpoint on the segment AB. So automatically the distance of the AM and BM is equal. So next is segment PM is equal to PM. Segment PM is equal to segment PM. This is the common side of triangle. This is the common side of triangle. Therefore, triangle PAM is equal to triangle PBM. Yes, 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 taste. That is side, side, side. Three sides of the triangle are equal, then this triangle should be congruence. Now the next part is here angle PMA is equal to triangle PMB. B, CACT. You can see in this diagram angle PMA and angle PMB are equal because this is the congruent triangles, and the angle of congruent triangles also the same. Therefore, but as we know, angle PMA plus angle PMB is equal to 180 degrees Celsius, because we take EM as a midpoint of segment AB, and if we draw the line from the M, it should be the perpendicular angle, that is 90 degree. It automatically form the 90 degree angle on the segment. That's why the PMA and PMB is equal to 180 degree. Now angle PMA plus angle PMA is equal to 180 degree. Both are the same things, just we need PMA. That's why we are focusing on PMA. Here 2 PMA is equal to 180 degrees Celsius. So what is the angle of PMA only? It is 90 degrees Celsius. Therefore, segment PM is perpendicular to segment AB. So let's give here 1, but point M is the midpoint. Point M is the midpoint of segment AB. This is the construction of our proof. So let's give 2 number for this. Therefore, the line PM is perpendicular bisector of segment AB. So point P is on the perpendicular bisector of segment AB. You can see here point PM is the midpoint of segment AB, which we have construct for the proof of our theorem. Therefore, the line, the M point, that is the midpoint M, is perpendicular to the segment AB. That is our proof. Therefore, the line M is the perpendicular. So perpendicular bisector of segment AB. So point P is on the perpendicular bisector of segment AB. This is the proof. So the next is properties of inequalities of sides and angles of triangle. Here the theorem is, if two sides of a triangle are unequal, then the angle opposite to the greater side is greater than angle opposite to the smaller side. This is the theorem we have to prove. First, let's draw the diagram. Two sides of a triangle are unequal, so we have to draw one side is little smaller than the other. Let's draw the third side. This is X, Y, Z triangle, in which the XY is smaller than the XZ. So what is given? Given is, in triangle XYZ, the side XZ xz is greater than the side xy. So that this is given. What we have to prove? What we have to prove? The angle xyz is greater than angle xzy. Angle, or you can say angle xyz is greater than angle xzy, which we have to prove. Now we need one construction to prove this theorem. What will be the construction? Construction should be like, take point P on the side xz such that xy and xp is equal, that is yp. We have to draw line xp on xz which is equal to xy, that is this length should be same. If I draw or take P point over here, so these two sides should be equal, that is xy is equal to xp, and draw the line yp. This is the construction. Now let's come to the let's write first construction. What we are take point P on side xz such that xy is equal to xp, and draw segment yp. This is our construction. I hope everyone understand. Now let's move to the proof. Proof of the proof in triangle xyp. In triangle xyp, there is xy is equal to xp, which is construction of theorem. The second one, but because of that, what happened? The triangle xyp is equal to triangle xpy. How? It is a isosceles triangles. Angle xyp and angle xpy, they are the equal, because two sides are equal, then the two angles opposite to that side is equal, that is isosceles triangles. Let's give one number for this equation. So next is angle xpy. Angle xpy is greater than angle pzy, because exterior angle theorem. We know exterior angle theorem, that's why angle xpy is greater than angle pzy. This is the exterior angle theorem. Therefore, what happened? Therefore, angle xyp is greater than angle PZY from point 1. Angle XYP is greater than angle PZY. This is the point from 1. Therefore, angle XYP plus angle PYZ is greater than angle PZY. It is because of if A is greater than B and C is greater than 0, then A plus C is greater than B. I hope everyone understand. If suppose A is greater than B and C is greater than 0, then we can write or we can assume that A plus C is greater than B. So next part, therefore what happened? Angle XYZ is greater than angle PZY. That is angle XYZ is greater than angle XZY. So that is our proof. Angle XYZ is greater than angle XZY. I hope everyone understand.